Hello, my dear students. So here is the answer key and solution of Super 6 work power energy. Yes, yesterday I have given 6 questions to you. So now that is what first the answer key of these 6 questions. Question number 1 answer is 8. Question number 2 answer is approximately 2 meter per second. Question number 3 approximate answer is 3.6 meter per second. Question number 4 exactly answer is AD. Question number 5 answer is 2. Question number 6 these are the answers, big answers, right? So that you can pause your video and see better. You can first do the self assessment, see how much marks you are getting, and then we'll discuss in detail the solution of each and every question, right? So first of all, like a trained student, first you need to identify what are the easy questions, because time allotted was what, 20 minutes. So in 20 minutes you had to complete as many questions as possible, right? So first you had to identify the easy questions, and those easy questions you should try to get the answer, and then you can move towards a lengthy question or difficult questions, right? Question number 1. In question number 1, if you see some force expression is given, and we need to calculate work done from starting point O to end point C. So obviously beta, it's looking like a difficult question, but actually it is a very easy question, right? Okay, not that easy, right? But what we need to do, first of all, by the expression, what is coming in our mind, that we have to do integration, right? So in this question we have to do what? Integration. So approach is integration only, the force is there. So then whenever any variable force is given, then we should first try to write this work, a variable work force dot displacement. So I'm getting this expression, right? Now this expression, it contains x, y, dx integration, x, y, dy. Looking like a very complex integration. How to integrate this, right? That I don't know beta. So I don't know much mathematics. So, but to solve this integration, we can take help from Mr. King. So Mr. King, very good student, right, of senior batch. So he's very good in mathematics. So he can directly solve this integration, right? But for me, or for some students who are not that good in mathematics, so what we can do better, we can learn one trick here, right? So whenever this kind of function is there, in which more than one variable is there in a function, and now we have to integrate it, so then we can do brainstorming, that in what way we can express this function, right? So if I am thinking for a while, then that idea can come in our mind, so that this can be written as derivative of x square y cube, right? So like these kind of brainstorming, Lalit do very quickly, right? But if you are not Lalit, if you are like me, so then it will take at least 40 to 50 seconds to just think that for what function this will become a derivative, right? And then on thinking, what will get, x square y cube, right? So x square y cube, if you will take derivative, so you will get but this function, okay? So I can write like this. Now differentiation, integration, cancelling out. So what now we need to put, we need to just put the values, initial value, final value, that's it, okay beti? So you are getting this answer 32a to the power 5, that is total work done. So comparing with the question, so 4n 8 power 5, so here this n or eta, that is what we require here. So your eta will become 8, okay, because your answer is 32 8 to the power 5. So please see this mathematical trick, very useful in many of the questions where we require integration. Okay, so now dear students, let's move to question number 2. Okay, so here also question, it is JEE advanced trend based question, right? So some dimensions are given to you, right? So approach obviously will be work energy theorem. Calculations are looking lengthy, but actually easy, right? And now from now we don't need to bother much about it, because in JEE mains notification also we have seen calculators are allowed, okay? So don't worry. Same kind of things you can expect in advance also, but let's see what will happen, right? So now the approach is work energy theorem. What is the wrong turn? So what can be wrong turn here? You are looking the tension at point A. So at point A, you are looking that tension is acting and displacement of the collar is towards right. So it is forming different angles. So it is forming different angles and work done is different at different points. So it's a complex mathematical problem, right? So you can move in a wrong direction if you're thinking like that, right? But if you are taking collar and the string also as a system, 300 Newton force you are applying here. So you can find a displacement of this point only, point of application of force only. So by that also you can find how much work you are doing, right beta? So that is what right turn. So where the force is acting, right? So 300 Newton. So now this length is 1.5 meter. So when the collar is coming here, this total length is 0.9 meter. It means how much the point of application of force has been moved by 0.6 meter, right? So work done by net forces plus change in the potential energy of the system. Calculation looking difficult but not that complex, okay? So work done by applied force, work done by spring force is equal to change in kinetic energy. And if we are solving it, approximately what we are getting? Approximately we are getting velocity as 2 meter per second. Okay. Now question number 3. Question number 3 is also a similar kind of question where we have to apply a work energy theorem beta, right? Then why I have given this question? Because I have seen many students getting confused here in writing constant equation. Like we know this block will follow a circular motion trajectory, right? This block will strike here with velocity say Vm, and now this point of the string is moving with velocity V, right? So from constant relation, first we can obtain relation between velocity Vm and V, right? But what to do? Shall we write Vm cos theta is equal to V or V cos theta is equal to Vm? So I have seen many good students doing mistake in this small mathematical step. So Vm cos theta is equal to V or V cos theta is equal to Vm cos theta is equal to V. See actually block is in motion, right? So block is in motion. So its a component along the length should be equal to velocity of string. So that velocity of string is basically that velocity of string. That means that is velocity of block. Okay. So what we should write here? So Vm, sorry, V is equal to Vm by 2. So that should be the right approach. Right, beta? V is equal to Vm by 2 means component of velocity of block in the direction of string should be balanced by velocity of string. Okay. So here we should not do any error. So otherwise question is simple only. So if this block is going down by 1 meter, now see this string beta. Between pulley and block initially length of string was 1 meter. Now block is striking here. Now what is the length of string? 1 meter down, this is 2 meter, and this by Pythagoras theorem that is what? Root 5 meter. Okay beta. So it means how much length of string is going up from this side. So root 5 minus 1. So then work energy theorem. Work done on capital M, work done on small m, change in continuity, and like this I am writing. So what I am getting Vm as 3.6 meter per second. Okay. By work energy theorem. Okay. Now question number 4. So now question number 4 is again a easy question only, right? So for these kinds of question only, I was saying properly we should first, like a trained student, select the easy questions. So that is the, I think, the most easiest question in a Super 6 section, right? So that one point you are moving with some velocity and acceleration which are given. right? And we need to tell about kinetic energy of block or rate of doing work by the agent or rate of doing work on the block, right? Okay, so whatever work you are doing on the system, that is basically rate of work done on the block, right? Because energy you are transferring to the block only, because string is massless, pulley is massless. So whatever work the external agent is doing here, that should be equal to change in kinetic energy of the block, rate of change of kinetic energy of the block. Now that is equal to what? Force on the block multiplied by velocity. Okay, so from first constant relation I am getting what, beta? Velocity of block in terms of velocity of point 1. So that I am doing, acceleration I am getting, then kinetic energy of the block I am writing. Okay, so rate of work done is net force into velocity. Net force on the block is what? 5t force. Means if tension here is t, then on the block what are the forces acting? 2t here, 2t here, t here, total 5t forces acting, right? So 5t is 5 Newton, velocity is 1 meter per second, so power will be force into velocity. So that is our answer. Okay, so answer should be AD. Okay, now question number 5. So this question I have taken from Pathfinder, right? And see what is there in the question, right? So many different values are there. Look, question is looking very tough. First of all, why? Too much information is there. First of all, what they are saying, between A and ground some coefficient of friction is given, mu1 is equal to 0.5. Between B and C also coefficient of friction is 0.85, that is given, and block and ground, that is smooth, so no friction here. So for this question a perfect idiom is there that I want to say: all bark and no bite, right? All bark and no bite. So means you should be ready for these kinds of question also in JEE Advance. In actual JEE Advance you should be ready for this type of question, where on the basis of data given or on the basis of situation it is looking very difficult, but when you go on trying the question, right? So when you are trying the question, actually the question becomes very simple. Like here I am trying to solve it. What is the initial spring force? So that is 240 Newton, right? And now if I am checking whether body A will move or not, limiting friction on A is what, beta? Limiting friction on A I am calculating, that is 250 Newton. It means the spring force here, now it is a compression, beta, right? If you see here, compressed by 0.5 meter, and here block B and ground, that surface is smooth, it means the compression will decrease, means the spring force will decrease only. The spring force will decrease, it means what, beta? So the friction required to stop motion of A is even lesser, means block A will not move. So block A will not move, it means this is the combination of B and C will start moving towards right. Between C and B there can be relative motion, that we can check by that pseudo force. Now here when compression is maximum, then only acceleration of combination of B and C is maximum. It means then only pseudo force acting on C is maximum, right? So pseudo force acting on C is a 2 into 8, because initial acceleration, combined acceleration of B plus C is 8 meter per second square. So pseudo force on C is a 2 into 8 means 16. And when I am trying to find out the limiting friction between B and C, what I am getting, beta? 17. It means here also relative motion is not happening. Between B and C also there is no relative motion, because initially only pseudo force is maximum. That maximum pseudo force only it is less than limiting friction. It means later on the pseudo force will decrease only. Okay, so it is just behaving like a spring block system, and that also a easy spring block system, right? So easily I am doing energy conservation. Initial potential energy of the spring is equal to final current energy of both B and C. So by that I am getting V as 2 meter per second exactly. Okay. So all bark and no bite. Please remember this. Okay. Now dear students, next question. Next question, a very interesting and tricky question you can say, where we just need to see what is the nature of spring force properly, right? The nature of work done by spring force here we need to see properly, right? So now let's say compression in spring 1 and 2 are x1 and x2. So total compression is x, and also two springs are in series. The spring forces should be equal. K1 x1 is equal to K2 x2, right? So total compression x1 and x2 you are writing in terms of x, right? Total compression. Now what is the crux point here? Block is moving very slowly. So if block is moving very slowly, right, it means work done by your external agent and work done by spring S2 on block must be equal and opposite, right? As net work done on block should be 0. Okay, so work done by applied force must be equal to, means equal in magnitude but negative, right? Your net work done on the block should be 0. So work done by F should be equal to negative of work done by S2, right? Okay. So now that I am writing, what now I am writing work done by B on S2 plus S1 on S2. Now if you are considering S2 as a system, as many things are required here, right? So what I am taking now, S2 only as a system. Now S2 is a massless thing, but it can store energy. So net work done on S2, I can say it is equal to increase in potential energy of S2, right? Work done by B on S2, work done by S1 on S2 is equal to half K2 X2 square. Now work done by S2 on S1 is equal to half K1 X1 square. Work done by S2 on S1. Why, BT? Because if I am considering S1 as a system, right, simply you can see here, wall is not doing any work because point of application of force is not moving. So whatever work S2 is doing on S1, that is only converting into potential energy of S1, right? So simply work done by S2 on S1, I am writing half K1 X square. So work done by B on S2 is equal to this quantity. Okay, beta. Work done by B on S2, right? Half K2 into X2 square, half K1 into X square, right? So this expression I am taking on the right side. Work done by S1 on S2 is negative of half K X1 whole square, right? Okay, so by that, by doing the calculation, I am getting work done by S2 on B. Oh, sorry, work done by B on S2 I am getting. So that is our one of the answer. Okay, work done by S2 on B is negative of work done by B on S2. So that is our answer. Okay, beta. Work done by F on block is negative of work done by S2 on block, that I already said. Okay, so by that we are getting all the answers. Okay, so here one more interesting answer, 0 or meaningless. What is that? Work done by S1 on block. So 0 or what you can say meaningless, right? Meaningless. Why? Because no interaction between S1 and B. So no interaction between them is how we can say work done by spring force like S1 on B, right? So that's why I said, right, written here meaningless. Okay, beta. So that are the solutions of all the 6 questions. Any question that you're not getting, please write in the comment section. Don't hesitate, beta, right? So all are JEE advanced based question. The trend is JEE advanced trend. Okay. Thank you.